Last week, arms just went up today. But it was free, so. Yeah, whenever you're ready.
Good afternoon, everybody. My name is Logan Lohr. I'm the project manager and structural engineer for GALS. I'm here to present to you today the design for Eastgate Development Project. So with me today is Roberto Alanis and Abraham Steinbeck, our transportation engineers, and Ryan Gibbons, our water resources engineer. So before we begin the presentation, we're going to go over a brief cost estimate for this project, and then each team member will go over their specifics in their section of the presentation. So for this project, each team member created a log for their work, their time spent working on the project, and that was multiplied by their rate that was determined last semester. And so overall, we have a total design cost of just over $66,000.
You share your screen? Professor Grossman says your screen's not shared.
Space.
The total design cost is over $66,000, and then each team member compiled a design cost that comes out to just under $10.7 million. So for the structural aspects of the project, we were asked to design a commercial building that's at least 16,000 square feet, and a senior living building that is at least 20,000 square feet. We're also asked to provide at least 2,000 square feet of covered outdoor space. So in order to design these buildings, we need to determine what kind of loads were acting on them. So we utilized ASC 716, the manual, to determine both the live loads and dead loads acting on the building. For the floor loads, we determined 100 PSF occupancy load, and a snow load of 22 PSF was calculated. And for the dead loads, there was a ton of dead loads provided, and we selected the largest dead load in each category. So that way we don't know what the developers want to furnish the building with. So in this instance, we selected a hardwood flooring as opposed to something lighter like a laminate flooring. So that way they can choose a heavier load and not have to worry about compromising the integrity of the building. So with the loads, we're then able to come up with a design for the buildings and then apply the loads to the buildings and model it in RISA. So here is the first floor framing plan for the senior living building. This design had the second floor offset to provide a covered outdoor patio for the residents of the first floor. It provides 4 entrances to the buildings here, 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 and here. This is to maximize accessibility for the senior residents. And here's the second floor framing plan. And it also provides a balcony for the residents of the second floor along the back of the building. In order to design for lateral forces, we place braces along the sides of the entranceways here and the stairwells, and as well as in between each of the units. This allows the client to basically furnish the building in any way that they want without having to worry about braces getting in the way of entrances or windows or things like that. So we plugged it into RISA, we were able to design it. RISA also designed the columns for us, which are the beams and all the columns and the braces. Here is the table of our beam schedule. This looks like a lot, but it's because we utilize shear studs, which I'd be happy to answer any questions you have about them at the end of the presentation. And here are the columns for the building. We range from a W6 by 15 all the way up to W8 by 31 columns. And they're based on how much load they're taking, span lengths, and where they are in the building. Once we determine that, we're able to design the connections for the buildings, which you can see here. So this connection is a beam to girder connection for, it's located right here as an interior beam to girder connection in the building. So this reaction is for 60 kips, and we utilized a double angle connection with 1 inch bolts and a 1/2 inch thick plate. This provides 68 kips of resistance. In a similar manner, we also designed the braces. Which you can see here, the brace connection. We used 4 1 inch bolts and a 1/2 inch thick plate to make sure that the brace is connected properly to the beam and the girders. And then we also utilized concrete slabs for this building. You see the ground slab here was designed for 3-foot span. We used a 100 PSF occupancy loading. This resulted in number 3 bar spaced at 16. And likewise, we used the 100 PSF for the floor loads and the 22 PSF for the roof loads, and 10-foot spans for both of those. In the same way for the commercial building, we also used the same roof loads. This is a single-story commercial building. Same roof loads here as we did on the senior living building. So here is the framing plan for it. We have load-bearing masonry walls all along here in each of these 6 units, and then steel joists that run in a shorter direction. So here is each of the walls. This wall runs parallel to the joist, which is why there's less reinforcement. It carries less load than the walls that are supporting the actual joist, which you can see down here. More detailed view is here. You can see we selected 10-inch concrete masonry units, number 5 bars spaced at 16 inches. We utilize long span steel joists and a steel roof decking. All in all, after we designed all these components, we were able to compile them into RS means to provide a line estimate. This cost estimate is just for the structural components of the building. But all in all, with the 20% contingency, we're at just under $1.9 million. With that, I'll pass it off to Roberto to talk about the improvements in the northern half of the transportation.
Thank you. Right, so Roberto with the northern portion of the transportation. I was tasked with connecting Sturdy Road and Still Havy Road while redesigning or designing the intersections at each endpoint. Additionally, I was to provide access and parking for any new developments or existing developments along this new development or this new road. And additionally, finally, was to provide some pedestrian access along this new development. Some criteria and assumptions. I assumed the road would be a collector road just because it would allow for an easier, less dense, more access to the new developments along these this new road. I designed for a WB50, and each lane I designed each lane to have to be 12 foot long, 12 foot wide, with a 2% vertical grade, and from one end of the pavement to the other end of the pavement was required a minimum of 36 feet for a collector road, and I designed for a 35 mile per hour road. This intersection is my Sturdy Road Chapel Drive. Sturdy Road Chapel Drive intersection. The radius at each corner is 30 feet. I went with a signalized intersection simply because when comparing this intersection with the increased lane, I increased the through lane by 1 lane. So with this new redesign, the level of intersection for a two-way or an all-way stop was much lower than the level of service for a signalized intersection, which was an A. So I went with a signalized intersection at this intersection at this point. On this end, I also went on this end, the Still Havy Road, Boilermaker Court intersection. I also went with a signalized intersection. Essentially, most of this portion has stayed the same with the addition of the new development. But at this end, I also went with a signalized intersection simply because a roundabout seemed to have a better level of service, but not by much. Both were still an A, but in this case, a signalized intersection is just much less expensive. These are the parking lots, and to your left is the commercial building parking lot. It is 290 feet long, and each parking spot is a typical 20 by 10 foot. The parking lot has 4 handicap spots, 2 of which are van accessible. And on your right, we have the senior living parking lot. Again, standard 10 by 20 parking lots with 2 handicap spots, and both of them being van accessible. The van accessible spots are a standard 12 by 20. I went with 2 separate lots instead of my first my first iteration, which was 1 connected lot, because it would seem it would be much safer this way, and with 2 lanes on the new development, there wouldn't be much congestion if there were two driveways. This is the detour plan for trucks. With the development I have, there isn't really much purpose to close down an entire intersection. The plan is to shift over the lanes, allowing passenger cars to pass through these intersections safely and simply. Trucks, however, would not be able to fit through. So instead, they would have to travel to they would have to go through US 30 or LaPorte and hop onto I-49. And this is how they would get around the development. This is the profile view. Each lane, as I said, is 12 foot wide. And we have two lanes going in either direction. I went with a 2% slope all the way down up until the ditch that we have one ditch all the way on the southern portion at a 3-to-1 slope with a 8-foot base. And as you can see, the sidewalk is over on that far end of southern portion of the ditch with a 4 foot wide. This is the total price came to about 3.5 million after everything was done, and I'm gonna pass it off to Abraham Steinbeck with the southern portion.
Roberto. So I'm in charge of the southern portion of Eastgate. So brief overview is that's a new realignment for Silhavy Road. There's gonna be a new parking lot for new Silhavy. Along with that, there will be a new pedestrian and bike path and a new intersection. So my design criteria, I designed for a W50 vehicle. Along with that, each lane will be 12 feet wide for safety reasons and for NDOT manual. This will also be in accordance with the bike path. Each turning radius will also be 35 feet in turn, and there will be a curb and gutter. My intersection is a 4-way stop. North, south, and east are all right through and left. The west is different because of the amount of traffic through a traffic impact study, so there is a left turning lane. As you can see here, this is my 4-way stop. You can see that there's a 35-foot turning radius for each turn, and then you can see westbound right here. You can see that there is a left turning lane. On my parking lot, there will be 130 spots. There will be 5 handicapped, and this is also including 1 van accessible spot. Back row that you will see shortly is for a drop-off spot for pedestrians and for baseball enthusiasts that want to go to the baseball diamond. They will be able to stop and get out and use the sidewalk to get to the baseball diamond. So right here, you can see that each handicap spot is the traditional 10 by 20. The 1 van accessible is 12 by 20. With this, you can see that there will be a sidewalk right here. This is the additional back row that is quite unusual for parking lots. However, I'm using this for a backdrop. Right here is my detour guide. You'll be using sturdy road to go through. And right here, this is the new Silhavy on the construction, so the road will be closed. I used a curb and gutter. I used a type B. The reason why is not because I wanted a type B grade, kind of what was mentioned further in Jolie's presentation, but there are different types like type A, B, and C. I use type B based on the parameters given by NDOT. It includes a 2% grade and a 1.5% grade. As you can see here, each line represents some gradient with the 10-inch aggregate, and then the 1.5-inch and the 2.5-inch asphalt. For my project costs, it came about $4 million. I'll be turning it over to Ryan Gibbons, our water resource engineer.
So here's the project overview. As you can see, at Salt Creek, I split into 2 sides, eastern portion and a western portion. Highlighted in pink is gonna be any culverts they're gonna be used. In red is the detention pond. In green are ditch systems that are gonna have silt sock check dams. The rain gardens in purple and sand pelters are in blue. The eastern portion of the site has a 1 acre size and the western portion has 40 acres. This is what my culvert 1's looking like. This is on the westernmost parking lot for the project. Comes out to a length of 70 feet, has a diameter of 2 feet, and it's made of corrugated steel. As you can see, the roadway in yellow is much higher than the water level for the culvert, so shouldn't flood over there when we get a good storm. Culvert 2, similar, also isn't overflowing the roadway. It's also a length of 70 feet and diameter of 2 feet, same material. This is located at the second parking lot. Culvert 3 is located at the crossing of Salt Creek. It has a length of 50 feet and a diameter of 3 feet. Needs to be a little bit bigger because there's actual creek running through it underneath the roadway, so gotta adjust for that, and it also, it's not overflowing the roadway, which is also good. It's my detention pond cross section. It's got a total depth of 6 feet, little deep. I'll have to put a fence around it because of that, but that's all right. It's got side slopes 3 to 1, and it's got a top width of 284 feet. Top view of the detention pond, it's gonna be 532 feet by 284 feet. Its capacity volume of 849,072 cubic feet. There's an outlet diameter of 0.5 feet. Overflow weir length of 38 feet, is a rectangular weir. And the rainfall depth used to calculate all this is 7 inches. For my ditch system, all the ditches on the site will have the same dimensions, 3 to 1 slopes, with depth, 20 feet wide. And this picture at the bottom right here, every 50 feet, if I want to put a tech dam in it, City of Valparaiso says to put them every 50 feet. So every 50 feet within the ditch systems, there'll be silt sock check dams. Here's a cross section for my rain garden. Foot deep, 31 side slopes, and 138 feet wide on the cross section. Rain garden top view, it's gonna be 270 feet by 138 feet, total volume of 36,450 cubic feet. And the overflow weir length for the rain garden is 38 feet. My sand filter cross section, sand layers 3 feet deep, gravel layers 5 feet deep. Got an under drain at the total of 8 feet deep. It's got a diameter of 4 inches. And then the side slopes for the sand filter are gonna be 4 to 1 for ease of maintenance. And then here's the top view of my sand filter. 35 feet by 8 feet. Sand filter hold 500 cubic feet, overflow weir length of 1.5 feet and a maximum head of 1 foot. Total cost for design and construction with a 20% contingency for the water resources section comes out to $1.3 million. That's the end of our presentation. Does anybody have questions?
Yeah, I don't know if I missed this slide, why do you need the sand box,
Sandbox?
sand filter?
Oh, I didn't mean to do that. You wanna fix that? I needed enough design work for the entire semester, so I have sand filter.
Okay, and why did you decide to reroute Salty Creek instead of like using Odd Creek? So.
I didn't, it's still going the same direction.
Well, that's not Salty Creek, isn't it?
I looked up on Google and Google told me that was Salt Creek. So Google could be wrong. That's Salt Creek according to Google.
I don't remember where I got Node Creek from, but I mean, they're the same creek. That's what we had.
I think they just have different names because maybe there might be a really long creek. It has a different name at different sections, but I looked it up, it said Salt Creek.
Yeah, because somebody presented a different creek than your Salt Creek. Okay, Roberto, I will maybe focus on the parking lot a little bit in here. Just if you remind me of the City of Valparaiso criteria for deciding on the number of parking spaces. So when you get this number of spaces, how did you get that number?
Right, so the way it works is they take the type of building and the estimated people, traffic that would be coming through, and the square footage of the building, and that's how you could.
So what is that criteria? So with that magical number in there, so how many parking spaces per how many square feet of buildings?
Off the top of my head, I don't remember. That's my bad.
And is the parking space standard? Because I heard both you and Abraham mention 10 by 20 and the 12 by 20. You mentioned that 1.11 by 20.
Yeah, so
which one is the correct size?
The standard size is most typically 9 or 11. I'm pretty sure it's 9 by 20 and then 11 by 20 for vans. I'm pretty sure, almost positive. But the main reason I went with 10 by 20 is and I remember this vividly because those are older people over on that far end. So and when I had them connected, I designed for older people, no offense, older people. So I went with a foot bigger just to accommodate for that case.
While we're talking, did you go to your first section of the roadway that you showed?
Section, this one?
There you go. 2% all one direction.
Yes. All the way to the ditch and then.
You're draining everything. It's sort of like super elevated.
Yes.
Reason is,
There wasn't really enough space over on this end. We wanted to do 2 ditches, one on either end, but when we looked at it, there just wasn't enough space to implement another ditch on the northern portion, on the northern side of the road. So we went with 1 ditch on the southern portion and made sure everything ran down that way.
So Ryan, I had a question about your sand filter.
Yeah.
So the sand is 3 feet thick?
Yes.
So did you use the method we talked about in class, or did you do this before we talked about that?
I did this before we talked about it. I don't remember which Carolina. It was one of the Carolinas. They have a design standard for sand filters. I used theirs.
But was the design method the same?
It was not, no.
Well, how did they do it?
They did it a weird way. I kind of figured it out. I could show you how I did it. I guess you'll see it in my design binder next week, but it was a little different for sure.
Did they have 5 feet of gravel with a 4-inch diameter selection system? Is that?
When I did the math according to how they had it, that's what I came out to. So yes.
Remember which Carolina?
It was either North Carolina or something. There's 2 to choose from.
Follow-up question, and again, going back, when you say I designed for WB 50 versus I hear the other saying 67 again, in my pattern, what's the difference?
It's the length between the pixels.
And so a fire truck is which one of those 2?
A fire truck?
And that's the same thing like
Yeah, mine would be a 67.
67 would be a semi.
Semi's a 67.
Fire truck is.
So that's the first thing like a plan review would do, just to make sure a fire truck would be. So Roberto is just to turn around and go the other way, it's not gonna work. So they should be able to have like access from both ends.
I believe they designed for W50s because it was in their scope statement to use W50s, so that's why.
I got a question just for Logan, because he threw it out there. We don't often see composite design and shear studs cost money, right? So what's the benefit?
Well, it helps with basically incorporating like so the slab and the beam are working together with the shear studs. So we're only using 12-foot stories, and so I didn't know what kind of things were going on with like the depth of the beams and stuff. So kind of like minimize the size of like the steel beams that we needed, allowed it to use the shear studs, allowed the beam and the slab to work at the same together. So it provides more resistance.
Thank you.
Me too.